So in this video, we talk about the von Neumann model. So we know that on the ENIAC model, all programming was done at the digital logic level. So programming the computer involved moving plugs and wire and OCAP set up the hardware component. Different hardware configuration were needed to solve every unique problem type, and wherever we have the new problem, we need to remove and also reconfigure the hardware component, and that's gonna require many days of labor and by skilled technician, and the model is not so flexible and very time consuming. So the inventor of the ENIAC, that's John Mauchly and Prosper Edgar, conceived the concept of computers that could store instruction in memory. So the invention of this idea has been ascribed to a mathematician, John von Neumann, who was the contemporary of the Mauchly and Edgar. So with that idea, the store program computer had become known as the von Neumann architecture system, and that's one of the breakthrough and fundamental of the today computer architecture. So the store program computer have the following characteristic. The first one is that the three hardware system. The three hardware system include the central processing unit, where all processing and computation gonna be performed in the CPU. The main memory system, where we can store and retrieve the information in there. The I/O system, where the interaction between the user and the system can be enabled. The next characteristic that the capacity to carry out sequential instruction processing. So it implies that there's a mechanism where the system can read the instruction and perform one by one from the beginning to the end of the program. The last characteristic, a single data path between the CPU and the main memory. So basically the single path is known as the von Neumann bottleneck, but the modern model allows you to have the multiple paths, so that can limit the bottleneck effect and also improve the performance of the system. So here the general architecture of the von Neumann model. So basically we have the three main components of the von Neumann model. That's the main memory, where we can store the program and data. The CPU, that's a central processing unit, include the program counter, the arithmetic logic unit, the control unit. All of them are interconnected, and the third component, that the input-output system, where the system can be interact with the user. So basically, the von Neumann model have the fetch, decode, and execute cycle to run a program. So what does that mean? Let's see. The first step is that the control unit gonna fetch the next instruction from the memory using the program counter to determine where the instruction is located. So this one kept a number or the indicating the address in the memory, and the control unit gonna go access to the memory, read the information there, and fetch into the arithmetic logic unit. So that we call a fetch step. Once the instruction is the fetch into the arithmetic logic unit, it will be decoded into the language that the ALU can understand. Okay, so that's the second step. That's the decode step. So if the once the instruction decode, and if the operation require any data operand to execute the instruction, the operand will be fetched from the memory and placed into the register within the CPU. So for example, the addition operation, we need a 2 operand, and the operand gonna be a read from the memory through the control unit through the arithmetic and put into the register in the CPU. So in the last step, that the once all the operand have been placed into the register, the ALU will execute the instruction and place the result in the register or the memory. So just depend on the instruction, but if we want we can get the result from the register and also store back into the memory anytime. So that's basically the operation cycle of the von Neumann model. So we have the fetch, we have the decode, and we have the execution. So that's the three main steps of the von Neumann model.